So our topic for today, more teas there, is techniques to tackle tech debt today. I've worked with dozens of teams and or dozens of companies, hundreds of teams, thousands of developers, and I've learned that tech debt is usually the one issue that every team seems to bring up. So I decided to dive into that a little bit more and talk about some different aspects of things that you and your team and your stakeholders can do to start addressing some of those tech debt issues. So we'll start with my shocking opener. Um, so my beautiful house here, I know that people love the background. Um, Been living here for about 6 years now, and when we moved, I noticed that I would walk into my closet and I would stand there like doing the John Travolta look because the lights weren't on. And I realized that I'd walk into rooms as well and the lights would still be on, even though I hadn't been in there for a couple of hours. And I realized that I'm kind of a lazy person. So at my old house, I'd gone and put the switches on the wall that do the sensors. So if I walked in, it would turn the light on. If nobody was in there, it would turn the light off. And even though I'd been a developer for a few decades now, and I was still smart enough to figure out how electricity works because there's just like three wires, right? You got like a white wire for something and a black wire for something, and then there's like a ground wire. So it wasn't too hard to switch those plates out. All you got to do is take the two screws for the cover, and then take another couple screws for the switch itself and pull it out and unscrew the wires and make sure they don't touch. And it wasn't a hard task, but I would have to go out into the garage and hit the circuit breaker, turn the power off, and then come back in the room and change the switch, and then go back into the garage and turn the breaker on. And that was a lot of work. So eventually I discovered if I just make sure that I don't touch the wires, I could just switch it out live. And I think I electrocuted myself about a dozen times in the period of a couple of weeks. Because even though I knew take the wire, bend it so it doesn't touch anything, I found every possible point of failure for something to go wrong. The screwdriver would slip and it would connect the lines and I'd get shocked. Or there'd be a little bit of tension in the wires. So when I would pull the switch out, they'd bounce and it would hit my finger and I'd get shocked. And the reason I'm talking about this is because I'm an idiot and I chose to be an idiot. Um, how many times did I shock myself for fun? I'm not going to share that. But the reason I'm bringing this up now is I had a real electrician come over and do some work for me. And there was no way that I was going to tell him that he didn't have time to turn off the circuit breaker. In some cases, he didn't because he was as dumb as I was or experienced. But I realized that for me, this makes sense because there are things that we do as professionals where we're hired to act like professionals. And there's a lot of areas where we know the right way to do things, and then we know kind of how to cut shortcuts. But I think the one thing we have to remember as IT professionals is we are professionals. And even if we decide to cut corners and do things quick because it's faster and easier, it doesn't mean that it doesn't have any impacts. And it also doesn't mean that other people can tell us how to do our jobs. Nobody has that authority to tell us to just make the change in production without testing it first. And to me, this is kind of important because a professional should act like a professional. And there are things that we may do sometimes because somebody else is telling us to do our jobs a certain way, which usually causes a lot of problems later. You know, writing the code, skipping the test, skipping the automation, all those types of things. And we have to deal with those consequences. So I wanted to make sure that, we're setting our minds straight on this, that we are professionals and the decisions that we make are having an impact on the work that we're able to do in the future, and also the way that, our stakeholders, our users, the management is viewing us. I'm not going to get into a real deep discussion about what is tech debt. I know that those conversations can be very nuanced, and we can get very particular about the details. I'm just going to put it in a very general statement is that, tech debt, the problem here is that tech debt is slowing our ability to deliver. So whether it's a bad pipeline, a flaky test, convoluted code where people are copy pasting stuff, I'm not going to get caught up in all those details, but I just look at that flow from the time that an opportunity is brought to the team until the point where we have an outcome. How easy is that flow, and how much work is it? How much wasted time and cognitive overload do we experience when we're trying to solve that problem? Oftentimes with tech debt, that cost of change gets to be very high. So naturally, if you go from left to right on this graph, the more code you write, the harder it's going to be. The cost of change, that blue cost of change here, is kind of that ideal. Yes, it's going to make some more, it's going to take more time to make changes as you move forward. But if you start getting a lot of debt in there, if you're not cleaning things up, if you're not addressing the problems, that cost of change with debt can start going up exponentially. And the real impact that we have to remember here is not just the experience for the developers, but our ability to meet the user's needs and the predictability of results. So we find that if you start getting a lot of tech debt and you find that it's harder and harder for your team to make your customers happy, be predictable, that's probably where a good investment could be made. And that's some of the things that we'll talk about today here. So real high level, I do have the slides. If you want to scan the QR code, it will show up at the end of the talk as well. But we're really going to focus on kind of three different areas here. We're going to talk about ourselves as developers, individuals. We're going to talk about the team and the stakeholders. So we're kind of starting in the middle and working our way out. At each level of that as well, too, we'll be talking about the technical things that we could do and interpersonal. So even though my background is in software development and I'm a technical person, we're still going to talk about some of the things that I've seen from an interpersonal side that people outside the non-coders can focus on as well. All right, so starting with ourselves first. First question is, what can you do? And oftentimes when I've talked to teams, they say, we're drowning in tech debt. We can't get this stuff done because we've got too much tech debt. And I ask, what have you done? And usually I get this answer, we've tried nothing and we're all out of ideas. One of my favorite Simpsons quotes here. So that first step is just abandon apathy. Don't just give up, like really focus. What is it that you can do instead of just complaining about it? Jerry Weinberg is a great thought leader in the consulting area. And he's got a real simple phrase here. Things are the way they are because they got that way. I've read his books. I reread his books. He's got some simple thoughts in there that really resonate. And the truth is, things are the way they are because they got that way. That's not a point to blame, but decisions were made. Knowledge was applied as best as it was at the time. We did what we could do with what we knew at the time. And that's just a way to say, yeah, we're going to acknowledge that things might not be perfect here, but we're not going to blame the past. This is our current state. This is what we have to deal with. So when we start thinking about what is it that we can do, it's good to kind of think about this, these circles here, right? At the center, you've got your circle of control. These are the things that you can control yourself. And the truth is, we can control ourselves, and that's the only thing that we can really control. We can't control others, but we might be able to influence them. So there are going to be some things that you have to take inventory on. What is it that you can do? And then we'll start talking about where can you influence things? How can you help other people see a better way? And what are those things that are going to impact you, but you might not have the ability to control or influence? This is helpful for me because it sometimes limits my scope instead of worrying about bigger issues, I can focus on some of these smaller issues and at least know that I'm taking some baby steps in the right direction. I need to put my name up here too. You miss 100% of the shots you don't take. Wayne Gretzky, Michael Scott, Dustin Thorstenson. If you're not trying to do anything, you're not going to succeed. So if you want to address your tech debt, you have to commit to it and you have to start making some shots. The responsibility process, you can see over my shoulder here, I've got that on the board. Just another framing of, there you go, Carter. This is just another framing of how people can focus on themselves and recognize the mindsets that they go through. You can do a bunch of study on this. I think it's one of the most impactful things that I've learned in my life. But we have this mindset, the stories we tell ourselves when things happen. Are we going to make production by the end of the month? Denial, you ignore that there's a problem. Oh yeah, we'll make it. There's no problem. As soon as we start seeing problems, we start to tell ourselves stories about blame. We would have gotten it done if it wasn't for Carter. We would have gotten it done if James did a better job. We would have got it done if Nick didn't create so many bugs. Next level up, when we're done blaming, when we're externalizing those problems, we start to justify. These are red because they're not healthy behaviors. We justify by saying, yeah, we never hit our deadlines. The deadlines are fake anyways. We never can operate that well. We come up with all these reasons why, again, the problem isn't with me. It's because of all these things outside of me. And when you're putting the problems outside of you, you're giving up your ability, your control to do anything about it. With the green areas here, the stories we tell ourselves have to do with shame. We would have made it to production on time if I wasn't such an idiot. We would have made it to production on time if I knew how to test better or if I understood that new framework better. I'm blaming myself and I'm owning the problem, but usually with pretty negative and destructive behaviors. And then a lot of times people just quit. The next time you're in a conversation with somebody where you see that, here's where we start and here's where we wanted to go, and then here's where things went wrong, you can watch people go through these conversations like clockwork. It's just a human thing, and there's nothing wrong about that. But eventually, you might be able to see those same things happening for yourself. And if you realize you're shaming yourself, maybe you start changing it to say, all right, I'm going to work harder. The team deserves better. I'm going to put the time in. I'm obligated to do the work. And that's kind of the have to, but don't want to mindset. It's usually a little bit more productive, but ultimately you want to be able to get up to this responsibility level. You're living above the line. You want to look in the future and see what would better look like. What is the thing that I want out of here? And then making a choice on what you're going to do to get it. Not working out of obligation, but choosing what you want to see happen. And responsibility isn't accountability. Again, it has nothing to do with blame, but it's our ability to respond. So if you're dealing with some tech debt issues, you have that ability to respond to that, and then you get to make your choices on what you want to do. And maybe there's a few things in here that might give you some ideas on where to start. Quick skill will matrix here. This is just, again, kind of that self-reflection. If you have the will to do something and you have the skill to do it, you're going to be in a good spot. You can make the changes that you want to see. This is a good way to look at other folks as well. If they have high will and low skill, or if you have high will and low skill, that means that you probably need to beef up your skill. You got to do some investments, some training, some learning, but that's okay. If you have the will, you can build up the skill. That's the easy part. If you have high skill and low will, now, or low will and low skill, these are some much more challenging areas to be in. So focus on yourself, make sure that your will is there, do your self-assessment on your skill, make the investments necessary. It could be some, morning work, etc. And the biggest thing with my fancy graphics here, if you find yourself in a hole, quit digging. If you have a tech debt issue because there's too much copy and paste code, quit copy and pasting the code. But maybe you don't know how to identify if you're in a hole, or you don't know how to identify when you're doing the bad things. This is an investment that you can make to identify code smells. So Martin Fowler describes code smells as symptoms of poor design or implementation choices. It's kind of hard to quit digging a hole if you can't identify that you're digging a hole. If you're not able to look at the code and recognize that it's a smell, maybe that's an area that you could beef up some of your skills a little bit. I'm due to time, I'm not going to dive into this example, but I'm assuming that the developers are seeing that and they probably don't feel real good about it. They might go, "Ugh, this is kind of icky code." We could go through and say, what exactly is it that's bad about this code? Industrial Logic has some training materials that I thought were very helpful. Again, these links are going to be available at the end of the slide. They actually go through that code base and they identify with names the things that are wrong with it. You see where some areas have some duplicate code, or we've got alternative classes with different interfaces. For example, get element at and get are really doing the same thing, but they got built at different times, and then the naming is a little bit different, so you can't scan it and see it quickly. You've got switch statements here. Oh yeah, I guess we're just looking at the instance of, instead of having a complex if block, we could have introduced a switch statement for it. Inappropriate intimacy, refused bequest. Basically, we have an interface that we have to implement that's not being used. These names, learning these names can be really helpful. So when you see the code, you can give it a name. Because if I talk about inappropriate intimacy with another developer, that's something that they can use as well. Carter, I was hoping that nobody would smile at that, because as soon as it came out of my mouth, I realized it was the dumb thing to say, but thank you. We'll edit that one out. If I talk about a switch statement with another developer, that's a term that they can look at somebody else's code and say the same thing. It's like, hey, what about using a switch statement here? It's better to articulate the things that we maybe feel instead of, so you can expand that to other people. Once you learn the names of those smells, there's a guide here that says, if you see alternative classes with different interfaces, what do we do to refactor that? How do we fix it? Well, we can unify interfaces with an adapter. We can rename a method. We can move the method. There's actions that you can take to address each one of those smells. So the quicker that you can identify a problem, and the quicker that you can know, here's the trigger, here's the response. When I see this, do that, then the code cleanup becomes a lot easier. I've seen teams where they would allocate a month or 3 months to address their tech debt. And at the end of it, their product people are unhappy because they did a bunch of work. They didn't get product new features out, and they didn't really fix anything because they didn't have the foundational knowledge to say, what are we looking for and what are we going to do about it? So these are some really good examples that you can learn about that more. Working effectively with legacy code and refactoring to patterns. A couple of books that are really foundational and have been extremely helpful for a lot of people. I hear these books referenced over and over and over. So do a little bit of reading, make it easier for you to see the problem and know how to fix it. I'm going to skip over the temporal coupling. Another thing is automated assurance. If you're making changes to your code, write some tests. Make sure that the way the code is working today is proven with automated tests. So as you start to implement a strategy pattern, you're going to move a bunch of code around, but at least you know that you didn't break anything, right? Give yourself that safety net to make sure that you can move forward with your changes quickly and confidently. A great Kent Beck quote, make the change easy, then make the easy change. People usually forget that red part here to say, warning, this may be hard. But I think about that all the time. Make the change easy. If I'm in a bad code base and I need to make one little change, I might have to change that code base in order to make the change I need very easy. Maybe I just want to add another strategy. That's the easy change, but to make it easy, it can be a little bit difficult. So we got to build that knowledge up. So how do you do that? I found code katas to be extremely helpful. So in martial arts, they'll go through these katas or katas, and they're going through the blocking, the punching, the kicking. They're doing that repeatedly so you get the muscle memory. So when you actually need to use any of those actions, it's automatic. You don't have to think about it. Usually when people are writing code, they're thinking about the business problem that they're trying to solve. With a code kata, you actually have the ability to focus on the work that you do, the way you write the code. So Gilded Rose is a great example. It's a messy code base. You can clone it. I'll share Emily Baish's GitHub repo later. You can clone it and go through the practice of refactoring it, extract methods, rename things, move it around, make sure it works. If you work on that muscle memory and you're focused on the way that you do the work, then when you're in real code and you're trying to solve a business problem, you don't have to think about the keyboard shortcuts to extract a method or to rename something or to move something to another file. You can do those things quickly and easily, and now that's not your blocker. You're not copying and pasting things and chasing compilation errors. And the more that you do that, you start getting this really nice dopamine kick. You recognize the cue. This is bad code. You go through the routine. You do the refactoring step. And then you get the little reward. And you keep going through it, and it's fun. You get a little dopamine kick out of that, and you're reinforcing these good behaviors. Now, if you're doing it all the time, you're not going to be sure if you're great at programming because you're always refactoring, or if you suck at programming because you're refactoring. But at least you try to focus on making it work and then make it right. And you're not going to solve everything. You'll start off with a big old nasty code base and you'll get something that looks good. And there's always still going to be more. But at least when you leave that example of what better looks like, you have the reference for other people on your team to see a better way of doing things. And maybe that helps them see the new code that they're working in and envision a better area instead of just going into a few different spots and injecting a couple of if statements for these emergent business rules. So keep improving incrementally. Now that we're done kind of focusing on ourselves, let's figure out how do we make our team better? How do we improve the team so they can start fixing some of these tech debt issues? If the kata worked for an individual, it works well for a team. I've learned that most people in technology go to college, go to a accelerator program, and they learn programming. Very few people learn how to work in teams. When we're watching YouTube videos or going on Stack Overflow or reading GitHub pages, we're usually thinking about the technical aspect of it, but we're not thinking about how do we work together as a team. Some people hate paired programming or mob programming because you're relying on some skills that are not technical, and usually people can't work together well. A kata is a really simple example where you can have the whole team working on the kata together, and then you can start learning, how do I communicate with the team? How do I tell them, go to line 42 and extract a method? Or maybe you have to say, select everything from 42 to 49, right-click on it. You'll find different ways to communicate and express your intent through words so somebody else can use them. And eventually, as the team works together more, again, doing some simple katas, they find that they can operate together well and they can accelerate. A lot of times, because we don't know how to work together well, we like this divide and conquer approach. We'll take a big problem and split it up into a bunch of pieces so individuals can go off and do their own work, and then it all comes together. Theoretically, this makes a lot of sense. This goes back to, 100 years ago when Henry Ford was creating the assembly line and they found a way to break a big problem into multiple small problems. In software, that doesn't seem to work. Usually what happens is everybody has their own backlog, the own things that they're working on. And as soon as a defect happens for a green team member, that's going to blow everything else up. So now that story, that task, that issue is not going to get done in time. If everything was split and, if it diverges, it converges and perfect, that's great. But usually you're missing individual pieces. So every time you try to optimize upfront by divide and conquer, recognize it's good in theory, but it seldom works out. Same concept with PRs. We love to write code and we'll throw it over the wall to somebody else to review the code. The problem is the person who wants that feedback, if they're relying on somebody else and that person has a different priority, they're probably not going to give you that fast feedback. So then you start on something else, you start a lot of things, but you don't really complete it. Not to mention when somebody's reviewing a PR, they're probably looking at the code and they're not thinking about what problem you tried to solve. So they'll make sure that the code is syntactically correct because it's easy to scan with the eyes, and they'll spot differences in spacing or you put your brackets on the wrong level, but they won't actually make sure that what you did is functionally correct unless you're working together. Mob ensemble programming, kind of a growing trend. A lot of people like working together. Some people don't like it because they think it's wasteful, but in all honesty, it's probably because you're just not doing it well. If you're doing katas and you're learning how to work together with a team, try actually following the rules for what mob programming is about. Try actually having very clear responsibilities instead of having 5 people watch one person code without talking. Try actually thinking about all the things that the team needs to get done so we can all focus on one problem. We can all make sure we're solving the problem correctly. We're thinking of all the different edge case scenarios and make sure that we don't have to have training later on. Get the team together, solve the problem, focus and execute and get it done. Teams that do ensemble programming well usually find that they're having much lower work in progress, lower WIP, and higher throughput. And once they learn how to work together, they actually enjoy it. If one person needs to leave for lunch, the work doesn't stop. The work can continue. Thinking about that concept of, the problem is greater than me, I think this is I should probably have a trigger warning on this slide. People often think that the product owners and the scrum masters decide the team's work because that's agile. False. I grabbed a couple of things out of the Scrum Guide. It doesn't say that the role of a Scrum Master and product owners to tell the team what to do. The Scrum Guide actually talks about it's collaborative work of the entire team. The team collaborates to define their sprint goal. The backlog is focused on the why, but it's a plan by and for the developers. There was never an intent to have a strict hierarchy where you have the workers writing the code and delivering the product and somebody else telling them what to do. The entire team should be working on this together, and your scrum masters and product owners and QA and developers should all be bringing their different perspectives and experiences together to optimize as a team. If you're not doing that, it's not because of how agile is. Agile isn't the problem. It's the interpretation or the implementation of how people are working. And these can be some difficult conversations to have, but they are very, very valuable conversations to begin. Focus. There can be a lot of things that teams are working on, and it's very easy to get overwhelmed with all the different areas. If you say that your code base is horrible and you've got all these different areas, sometimes there's some tools that might help you focus on where you want to put your efforts into first, instead of just saying, we're going to fix the code. Here's a link where you can actually review your GitHub commits, and you can take a look at the churn, the number of commits for each file, which files are we making a lot of commits on, and also the complexity. And as you go through that, you should be able to identify what are the prime candidates. So this file over here seems to be relatively complex, and it seems to be changing a lot. People keep coming into this file, and they keep tweaking and adding and modifying it. That might be a good place to start to say, let's get this one cleaned up so it's easier to work with. And this one, it's not being changed as much as the red one down here, but it's pretty complex. So if this file is changing a lot, but it's not that complex, leave it alone. If we've got something up here, which is really complex, but it just seems to work, that's that one big algorithm with a lot of regular expressions and dependency injection and all these other reflection things that are kind of hard to understand. If it ain't broke, don't fix it. Don't waste your time solving something that's not going to give you, some benefits. And these things here, these can be those areas that you say, when we're in there, we're probably going to clean it up, but maybe we're just not going to focus on that. So instead of looking at the entire problem of all the code base and trying to change everything across the board, keep focused on the things that matter for right now. And sometimes it's helpful to have a theme of the week. You can read the books, you can see all these different refactoring steps, you can see all these different code smells. It's very easy to just get overwhelmed and want to change all of the things. But if you've got a team, maybe the theme of the week is globals as parameters. So if you've got a bunch of methods with global methods in it, just tell the people for this week, if you see a method that has a global parameter in it or a stateful parameter in it, or sorry, a stateful reference, bump it up to be a parameter. See if you can make the method static. If the method's static, then you don't have to worry about the state and you can test it independently. Or maybe you want to just tell people, we're going to focus on extracting methods. If you happen to be in a code base and you see 3 levels of if statements and switch statements and all that, maybe just grab the contents of one if statement and pull it out into its own method. Just isolate it. That's just the thing that we're going to work on this week. Next week, maybe we'll start extracting classes. Maybe we'll start finding that we've got some common things and that 2000 line of code method is doing too much. So maybe we just start pulling things out into classes as is appropriate. You can have your stateless functions, like I mentioned with the statics. You can start to introduce patterns. If you see that people are newing up objects, let's just take that one and move it into a factory pattern. Maybe you've got a command pattern, adapter, observer, etc. If there are different patterns that you recognize exist in the code base, maybe each week you just have a different theme. So when people see that one thing, they recognize a trigger and they know how to respond to it. You're not going to fix it all overnight, but at least it gives you a little bit of growth to say little by little we'll make it better. James Grenning here talks about refactoring the spaghetti code. Sometimes you just want to make that a layered architecture. If you want to start taking some existing code, you don't have to do the whole thing, but if you could isolate that one piece, maybe that's a good first step. We talked about stateful methods and instances. Decoupling dependencies is a really good thing to focus on as well, too. Find some interfaces. If you have a lot of stuff going on in one spot, what does it really rely on? I used to change car stereos out when I was a kid, so this one speaks to me. I don't think kids care about that anymore. But the basic idea here is I could take this stereo and I could put it on my workbench and I could give it power. I could give it an audio source. I could hook up some speakers to it and I could make sure that the stereo I got from a pawn shop worked. If the speakers in the rear didn't work from the stereo, then I wasn't going to take the time to actually put it into the car. I was able to isolate that one thing, test all the different functionality of it before I would hook it up to the car. And you could probably do that with your code as well. Does the component that you're working on work well, knowing that it might reach out to some different areas that you can plug into later? Doing that helps us start to isolate things. I had one team that worked on a major website, and there was hundreds of developers on it, and they felt like they didn't have any control. So what they did is they introduced an iframe for their stuff. They figured out what are the parts of the website that they needed to integrate with, and they separated their component where they actually had their own delivery pipeline. So that team could go to production multiple times a day because they knew that their dependencies were well defined and they isolated the thing that they were working on. And it didn't mean that they never failed. They failed a lot, but that failure was very well contained. So every time they had a failure, they knew that it was in their area. They could respond, they could fix it. And that failure didn't expand to the entire website where everybody wanted to have more oversight on each deployment, which means you start pushing deployments out to every month, every quarter, every year. You end up getting more problems from that. So if you can isolate things and get better focus, that's good. Same thing with that isolation can be in your CI/CD pipeline. If you have one major pipeline for all of the code, what if you built smaller pipelines so you could make sure that your component worked? Maybe the result of that is it runs all the tests, it does the integrations, it kicks out a Docker image. And then at the end up here, maybe you have a couple more tests or a couple of checks, some approvals, which will make sure that all the pieces work together. If you put the car stereo in the car, you still want to start the car. You still want to make sure the steering wheel controls work. You want to make sure that your front right, your front left speakers are working properly, but you don't have to hold down the button to set your favorite on the FM station. That part probably works. You probably don't need to test that a CD player still works. And every time somebody changes the oil, you probably don't need to make sure that the radio still works. If they swap out the battery, that's a different area. Yeah, that's something that you might care about. But if you're testing everything everywhere all the time, you're going through a lot of work that might not actually provide you value. It'll slow you down. The scope gets too big. It's pretty frustrating. So start to move things into that area that you can control and figure out ways that you can have that control, that feedback, that confidence that you need to know that your component is good. Dealing with the rest of the application, that might be a different issue. And another thing too, as you're starting to pull stuff together, think about how you're organizing. This might look like a really nice toolbox or a workshop. All the wrenches are together here. You've got your pliers and scissors, and I would hope that they would at least have like some blue tape on the 10mm socket, because that's one that we all care about. If we're in a store, this is a really good layout because you're thinking about the thing that you need. You might be looking for a 10mm socket or a scissors or a pliers. This is good if you need the things that, if you know the specific thing that you need. This is a functional organization. Might look like our code base as well. We've got a services folder, a controller folder, a helper folder, a data access layer folder. We're organizing around functionality. So if I need to make a change to the person entity, I'm going to have to go to the person controller, and then to the person entity, then to the person service. I've got a lot of things that I have to jump around in. If you are organizing on the purpose, all the things that you have together are there together. So this would be an example of plumbing. I have different toolboxes in my house. I got a drywall toolbox, which has all the tools I need for drywall, including Band-Aids. I've got a plumbing toolbox, which includes all my tape and my wrenches and Band-Aids. I've got a car maintenance one, which has a plethora of 10mm sockets and Band-Aids. But I want to grab the toolbox that I need to do the job that I need. Now, that does mean that I have multiple tools, multiple hammers, multiple wrenches, multiple vice grips. I'm not optimizing on the tool, I'm optimizing on the purpose. So I think about that a lot when I'm looking at code or when I'm working on things, because I want to have the things I need and I don't want to have to think about how to get each different thing. Your tech debt, again, if we're thinking about the flow through a system, you want to grab the things that you need so they're there for you. If you've isolated your code, you might be able to start reorganizing it. So when you have to work on a person entity or the account entity, all the things that you need are right there. It's easy to find, it's easy to change, and you don't have to keep searching for things. I'd even go so far as to say with the team, having a UI team, backend team, DevOps team, database team, it's another example of functional organization. You're optimizing for the UI team and the backend team and for the database team. But what we want to do is we want to optimize for the delivery. So if you find that you have to keep talking to different teams, that will slow you down as well. And it's harder to solve the problem that you've enlisted to solve. All right, we got about 10 minutes left here, the stakeholders. So once we've thought about ourselves and our team, we're going to think about how do we deal with tech debt for stakeholders because they are part of it. I used to think about the Peter principle, which basically says that people are promoted to their highest level of incompetence. A person might do a really good job and get promoted, then they do a good job and they get promoted, then they get another promotion, and they've realized that the things that made them do good at their previous job aren't the things that are going to make them do well in their new job. And I used to use that as a weapon. I used to look at people and like that idiot's been Peter principled. I've since kind of changed my view on that. And I've recognized that a lot of people get promoted, a lot of people are in new positions, and it's hard. So instead of blaming somebody, I try to figure out what can I do to support them? How can I help them out? Part of it is understanding what the hierarchical flow is. When you've got your leadership, they've got things that they want. Those needs go downhill, 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 downhill. The poop all kind of cascades downhill. So if you don't like what one of your managers is saying, it's probably because they're responding to some other pressure and they're trying to not get blamed and make somebody else happy. So just recognizing that that's part of the environment, that you've got these motivations and goals cascading down and each person is afraid of blame, having a little bit of appreciation for that can change how you have your